Good day friends, this is day 7 of brake calculations of Baja Virtual Presentation Series. Please stay with us till end as we gonna share with you step by step calculation, and in the last we will also share you the slide layout of brake calculation. So here we have a certain objective before starting brake calculation. So first is we want 4 wheels to lock simultaneously. Secondly, we want less dive, or we can say we want less weight transfer after braking, and we also want less leakages in our brake circuit. So as per that, we gonna do our brake calculation, and that's how our brake system gonna work. So there are four key points. Firstly, brake calculations, which we gonna share you step by step, and components design. If you are customizing caliper or tandem master cylinder, then make sure there is a one key thing which you should give a good attention, that is seal grooves. So provide a proper seal grooves so that your braking system won't have any leakages, and do see of all the major components and minor components. Major components are brake caliper, tandem master cylinder, and brake pedal. And minor components, do see of mounting point of brake pedal, and also bolt which you are using for brake pedal, and also do see of knuckle point where your caliper is gonna mount. Next is component specification. So whatever components you are using, do a proper amount of research about it. As hydraulic fluids are there, so go through with the specification of dot 3, dot 4, then properly select the brake fluid. After that, same goes with calipers. Generally you are using for inboard, then go for Vespa caliper for each tire, as they are lightweight and they also provide effective braking. And if you are using outboard, then for front you can use Vespa caliper, and for rear you can go with TVS or TVS Apache caliper, or you can go with Willwood caliper, and there is okay. So, and hose pipe, I will suggest go with metal embedded. There is also rubber embedded, but metal embedded will provide you more efficiency while braking. So before starting, note down these abbreviations so it will be easy for you in further calculations. So there are a lot of abbreviations in brake calculation, like brake output of the pedal assembly, brake force applied, distance from brake pedal to arm pivoted to output rod clevis attachment. So like this there are around 20 abbreviations, so note down this. These are other remaining abbreviations, so do note down each and every one, and also note down its meaning of each and every abbreviation. So now we will start with calculation. So first step is brake pedal force. So brake pedal should be designed as to handle high bending conditions, and probably I section pedal will provide you proper strength, uh, proper bending strength, and also proper twist strength to your brake pedal. And our brake pedal is having ratio of 6:1. So brake pedal force is equal to pedal force applied by driver into your brake pedal ratio. So our driver can apply 400 Newton, that is 40 kgs, so into the pedal ratio. So we have got 2400 Newton of force. And then tandem master cylinder. This device helps us to convert force into hydraulic pressure. Tandem master cylinder used by us is of Bosch company, having a bore dia of 19.05 mm. So master cylinder pressure equals to brake pedal force upon area of master cylinder. So we have to take brake pedal force of 2400, which we have calculated, and area of master cylinder is pi into diameter square upon 4. So diameter, as we have used Bosch master cylinder, it is of 19.05. so area is 285.02 mm square. So our master cylinder pressure is 8.42. okay, so next is step 3, force generated by caliper piston. So we have used Vespa caliper which have 36 mm bore diameter and area of 1017.36 mm square. And so your pressure generated by caliper piston will be equal to the pressure generated by your tandem master cylinder. So we have taken 8.42 into the area of the pistons which are inside the calipers. So our piston have diameter of 36 mm, so area is coming up to 1017.87 mm square. So we have got force generated by caliper is 8517.46 Newton. And step 4, caliper clamp load. So caliper clamp load is twice of force generated by your caliper. So we have got caliper clamp load is 17,140.93 Newton. The caliper which we have used is fixed type, which consists of two opposing piston and pads which are made up of asbestos. The caliper are generated about 17,000 approx Newton of clamp force. After this force on disc by brake pads, so the friction force is equal to clamping force into your friction coefficient of brake pad. So the brake pad, if the brake pad is dry, then friction coefficient will be 0.4, and if it is wet, then it will be 0.1. So when brake pads will be dry, then our friction force on by the brake pads will be 6,000 Newton approx, and when it will be dry, it will be of 1,700 Newton. So torque, next is step 6, torque of rotor. So torque of rotor equal to force on disc by pads into effective radius of your disc. So the torque is coming up to 1165.58 Newton per meter, and we are using rotor of 170 mm dia and 3 mm thickness for both front and rear wheels, and it is made up of SS 410 material. So our step 7 is force on tire. So whatever our torque will be of rotor, so torque on rotor upon radius of your tire, so force of front wheels will be 3,990.34 Newton. Same for rear, as we are using inboard circuit. So for front on each tire it will be 3,990.34 Newton. Same for rear, and if we calculate total, it will be 15,961.36 Newton as total force on each and every vehicle, each and every wheel, as 4 wheels are there. So we have considered 4 addition of 4 wheels. Next is step 8, deacceleration calculation. So deacceleration of vehicle is equal to total force upon mass of the vehicle. So total force, as we have calculated, 15,961.36 upon weight of the vehicle, that is mass into gravity. So our deacceleration is 7.74 meter per second square, And step 9, stopping distance. Stopping distance is equal to velocity square upon twice of deacceleration. So our velocity we have considered is 40 km per hour. So in meters it will be 11.12. So as they have mentioned in the requirements that vehicle gonna deaccelerate from 40 to 0. So we have considered maximum velocity of 40 km per hour, and we have got stopping distance of 7.97 meters. And then step 10 is stopping time. Stopping time is equal to velocity upon deacceleration. So we have got 1.43 seconds of stopping time. Next is note down this abbreviation so that further static and dynamic loading on front and rear axle calculation we will require this abbreviations and these requirements. So distance between front axle to center of gravity, distance between rear axle to center of gravity, then distance between front axle and rear axle, that is your wheelbase, and CG height of your vehicle, and from the ground our CG height is 0.635 meter, and total weight of your vehicle, so it is 2060.1 Newton for our vehicle. So step 11 is static front axle load. So static front axle load is equal to your overall weight into the distance from rear axle to CG point. So remember, you have to consider distance from rear axle to CG point for front axle load, and for rear axle load we have to consider distance between front axle to point where CG point is acting, and so in denominator it is wheelbase for both. So for front static load on front axle is 781.41 Newton, and for rear it is 1278.68 Newton. Now step 12, dynamic weight transfer. So dynamic weight transfer is equal to deacceleration upon gravity into CG height upon wheelbase into your overall weight of the vehicle. So our dynamic weight transfer is 700 Newton, that is 71 kgs. And step 13 is percentage of front weight and percentage of rear weight. So our static front weight is 37.93%, and rear it is 62.06%. Now step 14 is dynamic front axle load and dynamic rear axle load. So for dynamic front axle load we have to add static plus weight transfer, so it is 1482.01 Newton, and for rear it is static front weight minus minus your weight transfer. So it is coming out to 577.4 Newton. Now step 13. Our vehicle has simultaneous locking system, and that's why our both front and rear wheel locks at same time. Okay, so after this disk thermal analysis calculation, so heat generated when apply braking action on disc brake is kinetic energy. So with the help of kinetic energy we have calculated heat generated. It is 12,983.71 joules. So from that we have calculated temperature difference of 24.61 degrees Celsius, and heat generated is equal to mass of the disk into specific heat into the temperature difference. So we have got from this formula we have got temperature difference of 24.61 degrees Celsius, and we have temperature difference, and we have initial temperature of 32, that is our atmospheric temperature. So we have got final temperature of 56.61 degrees Celsius, that is our maximum temperature will be generated after braking. So that's it. Our calculation part. So after this this is a slide layout, general slide layout of braking slide. So mention the circuit you are using, X split or H split or front rear, whichever circuit you are using. Show the layout of it, show the layout of also show the Ansys of disc pedal, and if you are using if you are customizing your caliper, also show C of that caliper, and also do Ansys of minor components like mounting point of brake pedal, and bolts, nuts and bolts, etc. So that's it from us. Thanks for coming and referring our articles and calculations. If you have any doubt related to automobile, please do comment, because we respond to each and every comment of yours. This is tvcalculation.com signing off, and do like and subscribe to our channel, because after this virtual series we're gonna cover Ansys and Hypermesh series, so you will get notified. Thank you.